Alright guys, and welcome back to my channel. Now, to go ahead and jump right in, we'll go ahead and be focusing on evaluating several limits of the expressions that will be given. Now, these expressions will get a bit more challenging as we go along, and let's go ahead and jump right in. So, for part A, you have the limit of this expression as x approaches 7. Now, some limits can be found directly through direct substitution, and this is one of those cases. And so by directly substituting x to be 7, we come up with the following equation. 3 times 7 divided by 7 plus 2 square root of. Now, 3 times 7 is just 21. And 7 plus 2 is 9, square root of. And so simplifying this further, we have 21 divided by the square root of 9, which is just 3, which condenses down to 7. And therefore, the limit of this expression as x approaches 7 is 7. Now, let's go ahead and try part B. Now, the only difference is we'll go ahead and start introducing a trigonometric function into this limit evaluation. And so in this expression, we're trying to find the limit of sine pi x over 2 as x approaches 2. And similarly, just like the last exercise, we can go ahead and plug in. And so we'll have sine pi x, or pi times 2, divided by 2. Using algebra to simplify the argument, we have sine of pi. And according to the unit circle, sine of pi is just 0. And so the limit of this expression as x approaches 2 is 0. Now, for part C, it gets a bit more challenging because if you notice, if you do direct substitution, you'll end up with the following form, which in calculus is known as an indeterminate form because it tells us nothing. And so somehow, in order to find the limit of this expression as x approaches 0, we're going to have to, through algebra, manipulate this expression into its algebraic equivalent. And so let's go ahead and get rid of this right here. Now, you have to get good at recognizing these patterns, but something that we can probably do to simplify this is probably simplify the denominator. And so what we'll write is the limit as x approaches 0 for x over x times x minus 1. Now notice that this expression right here is the same thing as this, but the only difference is that we've written it in factored format. So now that we have this format, notice that both the numerator and denominator have this x term in common. And so you can cancel them out, and by doing this, we get the following expression. The limit as x approaches 0 for 1 over x minus 1. And so now we can just go ahead and directly substitute the 0 into the x and evaluate this limit. By doing so, we come up with the following expression. 1 over 0 minus 1, which is just 1 over negative 1, which is just negative 1. So, the limit of this expression as x approaches 0 is negative 1. Alright? Now for the last one, we're going to be finding the limit of this expression right here as x approaches 4. But notice that if you plug in 4, 4 minus 4 is 0, and so this leads to a 0 in the denominator, which leads to an indeterminate form. And so through algebra, we're going to want to rewrite this into a more useful format where we can appropriately calculate the limit of this expression as x approaches 4. Now, in order to go ahead and do this, we'll probably want to modify the numerator since we have some square root elements going on, and we can probably multiply the numerator and denominator by the conjugate. And so what I mean by that is we do the following operation. So we'll have the limit as x approaches 4, and we'll have the expression that's given to us, which is x plus 5 square root of minus 3 over x minus 4. And we can go ahead and multiply this expression by the conjugate of the numerator. And the conjugate of the numerator is just x plus 5 square root of plus 3. And we'll go ahead and do the same thing to the denominator. All right. So now we have a pretty messy equation that looks like this. But through algebra, we can go ahead and simplify the numerator. And so go ahead and consider this expression right here. We have x plus 5 square root of minus 3, and it's being multiplied by x plus 5 square root of plus 3. And so now we can go ahead and just use FOIL to go ahead and simplify this expression. And so we'll go ahead and multiply this times this. And let's use another color to show this multiplication right here, and to show this multiplication right here, and then finally this one. And so taking care of the blue part first, the square root of x plus 5 times the square root of x plus 5 is nothing more than x plus 5. Now, for the first orange part, we have the square root of x plus 5 times 3. We'll just go ahead and have 3x plus 5 and the square root of. Now, for the second orange part, you'll have negative 3 times the square root of x plus 5, which is just negative 3 square root of x plus 5. And then for the gray part, 3 times negative 3 is just 9. And so notice that the orange part is the same number, but different signs. And so in this expression, we have a positive 3 times square root of x plus 5. In this expression right here, we have a negative 3 times square root of x plus 5. And so since they have opposite signs and equal expressions, they just cancel out, and all we're really left with is x plus 5 for the blue part minus 9. Forgot that mistake right here. There we go. And so simplifying this further, x plus 5 minus 9 is just x minus 4. All right. And so that takes care of this multiplication right here. And so we can go ahead and rewrite our limit as the following expression. The limit is x approaches 4 of x minus 4 over x minus 4 times the square root of x plus 5 plus 3. All right. Now notice that in this new fraction, you have an x minus 4 element in the numerator and an x minus 4 element in the denominator. And so through algebra, you can just go ahead and cancel those out, and we'll have an expression that says the limit as x approaches 4 of 1 over x plus 5 square root of plus 3. And at this point, it just becomes a direct substitution problem where you can go ahead and plug in 4 for the value of x without having to worry about getting an indeterminate form. And so doing this, we get 1 over x, which is in our case 4, plus 5. We'll take the square root of that, plus 3. Evaluating this further, you'll have 1 over 4 plus 5, which is just 9, the square root of 9, plus 3. And then we'll have 1 over the square root of 9 is just 3, plus 3, and you'll get 1 over 6 once you add those 3's together. And so the limit as x approaches 4 for the expression of x plus 5 minus 3 over x minus 4 came out to be 1 over 6. And that is your final answer. All right. So when it comes to these types of exercises in calculus, the reason why so many struggle is not the application of the calculus part. If you notice from this problem, the calculus part was just plugging x minus 4 into this expression right here. But it was the steps getting to this expression that was the hardest. And that is just algebra. And so if you can go ahead and get your algebraic principles down, knowing how to multiply by the conjugate, knowing how to divide, multiply, and recognizing several patterns, then applying the calculus part, which is just this, is going to be the easiest part. Alright? So I'll go ahead and see you in my next video, and we'll go ahead and talk about the topics of derivatives and differentiation using the formal definition of a derivative. Alright? See you soon, guys.